anybody who needs it, for anybody who is absent. All right, let's get started. So, hopefully you wrote the title. It's just a continuation of what we were doing before. This is our last day in measurements. Some of you may be sad, some of you may be happy about that. Happy about that? And our last topic is density. So, go ahead and write down the formula. It is a formula. So I'm going to put a box around it. The formula for density is the following, and you will have some formulas to work with in this class, here and there. This is the first one. The density of an object is its mass divided by its volume, always. For liquids and solids, oh, the formatting got weird here. Let me see if I can fix it real quick. Let me see if I can fix the formatting. Just take out this part then. I don't want it to be confusing. Here we go. All right, so we're only going to be working with measuring the density of liquids and solids. So you need to write the formula. And you need to write that the unit for mass that we will take our measurements in is grams. You know from the exercise we did with the scale last week that every measurement is supposed to be in grams. And so our measurements for mass are going to be in grams. And our measurements for volume are going to be either in milliliters or in centimeters cubed. Now, you should note, so I'm going to write it for you now. Milliliters and centimeters cubed are actually the same exact volume. So you should write down that 1 milliliter equals 1 centimeters cubed. We use milliliters when we're reading off of graduated cylinders for liquid volumes, and we use centimeters cubed for solids. But you can write either milliliters or centimeters cubed. They're the same thing. So you want to get this down. And so what density describes while I'm waiting is how heavy an object is. If you have your phone versus a piece of paper, can you figure out which one's heavier? It's going to be your phone. Every object has inherent density. When you compare water to other objects, for example, if you take a metal and you throw it in water, like a penny or a nickel, would it sink or float? If you throw a penny in water, it's going to sink, right? That tells us that the penny is more dense than water. Even though there's more water present, the penny sinks because it's a denser object. And so density is a property of a material. It's always the same. So we can determine a material's identity based on its density as one of the factors. Yes? Buoyancy. So that has to do with an idea called buoyancy, and also it has to do with the relative ratio. Like, there's a couple of different factors. One of them has to do with how much muscle a person has. If they have a lot of muscle, it's very hard to float. All right, are we good here? Continue? Wait, okay, I will wait. Density is an example, while I'm waiting, of something called an intensive property. And what that means, are we good to go now? Almost? Now? Okay. So you do need to write down these definitions because Cambridge expects that you do know what they are, but they never really bring them up very often. And so there are two different types of properties of objects called intensive versus extensive properties. And I'm going to give you some examples of each so you have an idea of what this means. Density is an example of an intensive property, which means that no matter how much or how little I have of an object, this property is always the same. So if I have a little bit of water or if I have a lot of water, it still has the same density. What other examples of intensive properties could you think of? Are there any other properties of a material that would stay the same if I have a small amount of that material or a large amount of that material? Color. That's an excellent first choice. So color is another example of an intensive property. There's another one for materials, how soft or how hard they are is also. And so there's something called hardness. Or what else? It's the same idea, yes. What about for water? Does water have a specific boiling point? Does it have a specific temperature it always boils at? So would you call boiling point an intensive property? That no matter how much water I have, it's always going to boil at the same temperature. It might take more energy to get to that temperature, but it's going to boil at the same temperature. So we would say boiling point and melting point are also intensive properties. And so these are examples of properties that are always the same for a material based on the material's identity. And so what's the difference between that and an extensive property? An extensive property, it does depend on what I have. And so there's actually very few extensive properties. I'll give you some examples. And we are predominantly going to be measuring extensive properties today. Extensive properties, if I cut a small piece of my jacket or my sweater, or I have the full sweater, what would change if I have just a small piece that I cut off versus the whole sweater? What would change? The size. And so measurements we can take for that are the mass and the volume. So examples include mass, volume, anything that changes when I increase the amount. It could even include energy. If I have more energy, like if I have a bigger hamburger, it has more energy, it will provide me with more fuel. And so actually also mass volume, and you could even write in energy. There's an equation with that, not in the pre-ACE class, but there is an equation with that where you get to actually explore that extensive property in the ACE course. We'll predominantly be working with mass and volume here. Depending on what's in it. If you take, so there's a couple factors here, right? There's the caloric density of the object and the amount. So as I said, if I have a small hamburger versus a large hamburger, the large hamburger is going to provide me with more energy. But if I have a small hamburger versus a lot of celery, the small hamburger will still provide me with more energy because different materials, different objects have different amounts of energy inherently in them, if that makes sense. So you have to compare apples to apples is a way to say it. The more I have of the same object, the more energy. So if I'm talking about food, the more I have of the same type of food, the more energy it's going to provide. Yes, that's true. And so this even goes into body size. Like the smaller you are, typically the less energy you need. The larger you are, the more energy you need because your body processes require more energy. So energy, yes, is an extensive property. All right, so you needed to know the difference between intensive and extensive properties, and I'm teaching this here because density itself is an intensive property. I'm going to bring this up for the lab, why this matters, because it does matter in the lab. You've got about 20 more seconds, then I am going to move forward. What I wanted to do we show you some examples to solve for density, taking a look at some of the type of math you need to understand to be successful in this course. Kind of gives a preview. And then I'll talk about the lab after that. Ready? All right. So don't write anything here, please. This is just a chart that shows you a comparison of densities of different materials. Different materials have their own separate densities. In the lab today, you're going to be given a chart. And one of the things you're going to have to do is find the density of a material and use that density to determine what the material actually is. Because that's one of the properties of a material. You can see that metals are very heavy. They have bigger numbers. And we know that they sink in water. They are very heavy. And if I see a number less than 1, that means that the density is actually lighter than water. So, for example, ethanol, gasoline, lighter than water. All right, so let's get to the math. Examples. So this is example number 1. And as always, I like to do the most straightforward example first. So go ahead and write it down. We're going to work through a few examples. And then I'm going to explain the lab before we go to lunch. So when you come back, you'll have the full hour. So, density practice, question 1, you've got a sample of copper. Yes. Yes, you can go. You've been provided, it has a mass of 3.1 and a volume of 0.35. What is the density of the copper? So the first thing you're going to want to do is write your formula. Density equals mass over volume. Now here's the deal. You don't have to write out all these words. You could write instead just the first letter of each word and it means the same thing. So you could just write out D equals M over V, and that's just fine. You need to write as much as needed to understand what you're doing. So in this question, training wheels are on. You're told in the question what the mass is and what the volume is. So how are we going to determine the density? So you would do 3.1 G divided by 0.35 ml. So far, so good? Now, the operation is a division because you see this line here. So you're going to do 3.1 divided by 0.35 in your calculator. And what does that give you? And you can use your calculator, you can use the decimals. That's a lot of numbers. Have we learned how to round this properly? Let's review those rules again, right? You're going to, because it's a division, and this is why I said, that's why I teach it first, because as we go through the class, you're going to come back to those rules to round. 3.1 has how many significant figures? 2. 0.35 has how many significant figures? So where do I round my answer to? It would be 8.9. You only write 2 significant figures, right? And 8.9 what? Grams slash ml, because that's what you have here, grams over ml. So it's just dividing the 2 numbers for this first one. Just remember that you have to apply the rules for rounding as we go through the class. So this had 2 significant figures, that has 2 significant figures, so our answer must have 2. Yes. So, as I said, training wheels are here. Training wheels are about to come off. You are expected to know whenever you see a measurement in G, that G is a mass. And if you see ml, that is a volume. That is going to be an expectation that you understand that when you see those units. Yes. Oh, did you have a question? I thought you were raising your hand. Yeah, did you have a question?
I was just going to say copper penny, 3.1 G, and 3.5.
Mm-hmm. Now, interestingly enough, we're not there yet, but when we get into alloys, metal alloys, pennies actually aren't made of a lot of copper these days. They're only made of a small amount, so this has to be, I'm sure, a very old penny. All right, density. Practice problem number 2. So I wanted to give you each scenario so that you can see how to manipulate the formula. You've got the density of CCl4 is 1.14 G/ml. This time you're provided with the density. If you have 134 milliliters of carbon tetrachloride, how many G of it do you have? So write your formula. We know this is density because density is mentioned. So D equals M over V again. What am I given this time, though? Density. What else? So you have to recognize that that's the volume and that this is the density. I'll pause because I know you're still writing the question, and then I'll continue to solve. Pulled it up from the last one when I posted everything for lesson 2. All right, so where I see density, what am I going to plug in? 1.14. Here's a question. Do you have to plug in the units? You don't have to, as long as you know what your answer's supposed to be in. We haven't done unit canceling yet. If you understand how units cancel, then you can plug in the units, but if it just confuses you, just put in the numbers to see what you have to do. So if I plug in 1.14 for density, I'm solving for mass, and for volume, what number would I plug in? 134. So what would we do now? Go ahead and, what would we do? Atul. Do you have? I thought you raised your hand. Multiply what?
1.15.
Correct. So the idea is we want to solve for mass. So if this is a division, we have to do the opposite, which is a multiplication. Now we would multiply both sides by 134. I'll get the door shortly. And then it's just simply multiplying these two numbers. 134 times 1.14. Welcome back. We would use our rounding skills. Calculator gives us 152.76, but how would we round this? I get 152.76 from my calculator, but where would I round it to? Go ahead. Why 2? That is the 1, and the 4 are significant, so that's 3. This is 3, so my answer should be 3. So it's going to be 150, again, 3. 153. And what is the unit? How do I describe my answer? G. And that's my final math. All right, so that was scenario 2. You're provided with the density. You're provided with the volume. We're going to take a look at scenario 3. What if you were provided with the density and you were provided with the mass? I'm pausing a little bit for those of you that are still finishing writing the problem down. Yes. Are we good to move? Practice number 3. After this one, we're going to take a look at what we're going to do in the lab. So I'm going to give you a moment to write it down. This time you're given density and you're given mass. As I'm doing that, I'm going to also post the lab groups so I can get ready to talk about the lab. So start with your formula. We know that it's density equals mass over volume. Now what do we have? The density and the mass. You're expected to know that grams is a mass, that you're measuring mass when you measure grams. So you would plug in 1.14 where you see density, and you would plug in 25 where you see mass, which means this time you're going to be solving for volume. Now the math here is a little bit harder for algebra, right? Because you're solving for something that's on a denominator. So I'm going to show you the algebraic method first, and then I'm going to show you a shortcut if you hate algebra. So let's do the regular method first, which is using algebra. How would I solve for volume here? V is on the denominator. How do I get it out? Go ahead. Move it to the other side. And we do that by multiplying both sides by V. It's the same thing as what we would call multiplying by the reciprocal. This. You cancel out the V on the right side, and you've got this right now. Then what do? Divide by 1.14. You end up with this. If you understand this process, then this is what you should use to solve. 25 divided by 1.14, and that gives me 20. How many significant figures? 2, because of this, right? 2 significant figures, 22, and the unit. What's my proper unit here? Volume is going to be in ml, so 22 ml. If algebra is not your strong suit and you struggle with solving for values in a denominator, there's actually a shortcut method to solve density questions that I'm just going to show you real quick. And I have seen it used in the international curriculum, so that's why I'm going to go ahead and share it. It's this. You can make a little triangle. If you memorize the triangle, you can use this method. Write a line here and a multiplication, just for yourself to remember. What this does for you is you can look at whatever 2 parts you have in this formula, and you'll see if they're above each other, you're automatically going to divide them. And if they're right next to each other, you automatically multiply. So this means if I have density and volume, I always multiply. If I have mass and density, I always divide. And in that order, mass is on the top and density is on the bottom. And density itself would be mass divided by volume. So if you look back at this question and use that method, you would say, okay, I've got mass and I've got density. My formula is automatically that, mass divided by density. And you don't have to do the math. You would just do volume equals m over d, and then 25 divided by 1.14, and the answer would be the same. So this is an alternative method. It's called a shortcut method. If you're not comfortable with the algebra of the formula, then that's the method you would choose to use to solve the questions. I will leave that choice to you. Write it down if you want. If you prefer to use the algebra, you don't have to write it down. You don't have to memorize it. We are about to talk about the lab, so I'm going to leave this up for about 30 more seconds, and then I'm going to talk about the lab you're going to do today. While I'm waiting for you to finish writing, I'm going to start passing out the lab papers. I would like you to check on Google Classroom to see what lab table number you have. I tried to put requests together for those who wanted to work with certain students. If you didn't put that you wanted to work with someone specific, I just grouped you together with someone else who said they didn't want to work with someone else specific. If you don't like your lab group today, you can make requests for the next lab for any changes. Yeah, refresh your page on Google Classroom. It should show up. I put requests together for the multiplayer strategy. You're welcome. All right, so the first thing I want you to do while we're getting ready, your name and your lab table. Identify your lab table so you know when you come back from lunch where you're going. Here you go. And here you go. Write your name and your lab table. Name and lab table. All right, so let's talk about the lab before we go so that we're prepared. I wanted you to write your name and your lab table. I did put it on Google Classroom. If you're unsure, I'll put it up on the screen when we come back from lunch so you can look. Some things you need to know before we do the lab. First, whenever you are asked to measure mass, the first thing you want to check on your scale is that it measures what before you put anything on it. Do you remember? So it's use digital balance, and what should it show? It should show grams, and it should show 0.00 G. This is what you should see. If you see any other number that's not 0.00, what should you do? There's a button in the middle you press. Reset. The balance is the tare key. It's called tare. So that will reset it back to 0.00, and then it'll measure whatever it is that you're measuring. So that's the first thing you need to know. Whenever you measure mass, you use the digital balance. When you measure volume, it's more complicated because you'll be measuring the volume of both solids and liquids today. So the first one I want to talk about is liquid. Measuring volume. If you have liquid, you're going to use a graduated cylinder, which is this thing. I'm a terrible artist, I apologize. But it's this. It's got a wide base, and then you looked at it last week. I put some out at your tables. Do you remember where to look when measuring the volume of a liquid? Go ahead. So there's going to be a little dip, right, in the line, and you look at the bottom of the curve, and you must measure. So you may want to write this note. Measure the nearest 0.1 ml. That's what it does. It measures to the nearest 0.1 ml. So if you were asked to measure 25.0 milliliters and you measured 25.1, you need to write what you actually measured, 25.1. This measures to the nearest 0.1 ml. This matters for significant figures. So that's why I'm bringing it up. So if I've got a liquid, I use a graduated cylinder to measure its volume. Now, what about solids? We can measure the volume of solids. There's a few types, though. The first one that we're going to measure today is called a rectangular solid. And so a rectangular solid, to get the volume, you have to use some methods from mathematics. Volume is length times width times height. So the volume will be the length times the width times the height. What unit do you measure length in this class? Do you remember? It's going to be centimeters, right? What would we use to measure centimeters? We're going to be using a ruler. So ruler will give you measurements in centimeters, and you're going to measure length times width times height. centimeters times centimeters times centimeters will give you a final unit of centimeters cubed, which is volume. And so your answer would be whatever in centimeters cubed. So far, so good? The second type of solid is a cylinder. So you'll be measuring the volume of a cylinder today. And the cylinder is a rubber stopper. Welcome back. And you'll want to write down a formula for this. When you get to the rubber stopper, this is the formula you need for volume. Volume equals pi r squared h. What is this? If I have a cylinder, which I'm a terrible artist, I apologize. I'm doing my best. The radius is the halfway point distance of the circle at the top. That's called the radius. And the height is from bottom to top. You're actually going to do it. You're going to take these measurements. You're going to measure the volume of the cylinder. If this is centimeters, and this is centimeters, and this is centimeters, what's your unit for volume again? Centimeters cubed. Because it's going to be centimeters squared times another centimeter. So that's centimeters. It's going to be centimeters cubed again. Finally, irregularly shaped object. Is a nail. You're going to have to measure the volume of a nail. That doesn't have a regular shape. So in order to measure the volume of something that doesn't have a regular shape, you actually use this method. You measure the volume of water, you put the nail in the water, and then you measure how much the volume changes. And that will tell you the volume of the nail, in our case. So we're about to go to lunch. I just wanted to show you the different things you're going to measure before we leave. When you come back, just to make sure that you're clear, you are going to take your seats and bring them to lab tables carefully. You have to return them at the end of class. For the lab itself, you turn it in individually, but you collect your data together. Think about with your lab partners who your group members are, who's doing the experiment, who's collecting the data, and who's cleaning up. The lab is going to be due next Wednesday. So it's going to be due next Wednesday at the beginning of class. You need to get all your measurements done today. You'll have the full hour when you get back. So when you get back, start organizing yourselves. Have a wonderful lunch. I'll see you shortly.